Hey guys, this is Mrs. Tran-Bloom. We're going to pick up where we left off from yesterday's notes. So yesterday we started on example 3. The directions is, use the information given about the angle theta, which is unknown. But I do tell you, theta is within 0 and 2 pi. And to find the exact value of yesterday, we did 1 eye, 2 eyes, 3 eyes, and 4 eyes. Okay, so today we're going to go finish up 5 and 6 eyes, which I'm going to use the back because I'm completely out of space on the front. Okay, so let me copy what 5 is. 5 says I want to find tangent of a double theta. Okay, so tangent of a double theta. And then I'm just going to write 6 out as well because I don't want to have to flip it back again. Okay, 6i says tangent of a half angle. Excuse me. Tangent of theta divided by 2. Okay, and let me just give myself a reminder where. So theta is between 0 and 2 pi, and theta was in quad 3. So let me just draw theta out really quickly. You said theta was here from yesterday. You don't have to draw this out again because we have already you guys already drew it out yesterday. Okay, so, and theta, cosine of theta is negative 2 over 5. Negative 2 and 5. And we said this is going to be a rad 21 negative. Okay? So this is the information that we already had from yesterday. Alright, but before I start, let me tell you a joke. Because I know my toddler jokes, right? I'm silly. I'm about 4-year-old. Alright? So here is the joke of the day. All right. Let's see which one I want to use today. What did one calculus book say to the other? What did one calculus book say to the other? Don't bother me. I've got my own set of problems. Ha ha ha. See, math books, we have problems inside, right? Anyway, so that is our joke of today. The reason I want to tell you is because normally I tend to forget a joke or two at the end. So I want to tell you ahead of time to get it out of the way. Is that all right? Okay, so tangent of double angle. Did I give you a formula for double angle? Oh, I didn't? That's okay, right? Because I don't need a formula for a double angle of tangent for tangent. I can just find it myself. So let me just move this around real quick. There you go. Okay. So tangent of a double, okay, it's really sine of a double divided by cosine of a double. Is that okay? So if you know sine of a double angle, then we should be able to find, if we know sine and cosine, then we would be able to find tangent of a double. Okay, and that's where we're going with this. So let's find out what sine formula is for a double. Okay, let's write it out. I'll give you a second to write that out for me. Sine of a double angle. What do you think it is? Hopefully you're writing 2 times sine of theta, cosine of theta, and divided by cosine of double. Cosine of a double, you have a few choices. Okay, so this one, you can write cosine square of theta minus sine square of theta, or you can use 1 minus 2 sine square of theta, or you can use 2 cosine square of theta minus 1. So it's really up to you which one you want to use. Right, so let's plug in some basic stuff. Here we go. 2 times sine of theta. Sine of theta is going to be opposite over hypotenuse, so negative rad 21 all over 5. Please check my basic math. Times cosine of theta is going to be negative 2 all over square root of 20. I'm sorry, negative 2 over 5. See? Almost. Okay. All of that is divided by cosine square, so that's going to be negative 2 over 5. Square minus sine square, negative rad 21 all over 5, and just square that. Okay, so this is a negative right here. Just want to make that clear. Okay, so let's multiply it out. So this is going to give me a negative times a negative. That's going to be a positive. So we're going to have a positive 4 rad 21 all over 5 times 5 is 25. I'm sorry, I meant to write 21. Okay, in my head, I was already multiplying out the denominator. Okay, I'm just going to do a division sign for this piece. Negative 2 over 5 squared is going to be a positive 4 over 25. A negative 21, rad 21 over 5 squared is going to be a positive 21 over 25. Okay. These two have the same denominator, so I'm just going to quickly... Did I mean to write this as a positive? I did, huh? So this is a positive. Positive 4 rad 21 over 25. These two, the denominators are the same, so I'm just going to put it over one denominator. Okay. I am shown a lot more steps here, but if you feel like you don't need to copy the basic stuff down, if you're in pre-calc honors, you can skip it. Okay. But make sure you understand how we're going from one to the next. So we're going to divide. 4 minus 21 is going to be a negative. Negative what? Thank you. When we're dividing, we're going to take its reciprocal. So 4 rad 21 over 5 times 25 over negative 17. These will cancel. So now we're ending up with a negative 4 rad 21 all over 17. So that is our tangent. Okay. So again, you can pick, for the cosine, you can pick one of the 3 identities that we wrote yesterday. Now tangent half. Okay, so yesterday I definitely gave you a tangent half equation. 3 of them to be exact. The sine half, cosine half, and tangent half. And then we were about to prove it, but you guys were kind of out of it. So I said you guys can prove those 3 identities as an extra credit. So far, I have received 2 papers, but both of them were identical, and both of them only wrote 1 proof. So at this point, I don't have anything that's 100%. So tangent, okay, of half is going to be plus or minus. We can do a sine half divided by cosine half, right? Because that's really what tangent is. Okay, but yesterday when we did that, we said, hey, we have a formula. 1 minus cosine of theta divided by 1 plus cosine of theta. Okay, so that's our tangent half. So we're going to use the same picture here. Let's decide whether this is a positive or negative. Currently, theta is in quadrant number 3, right? 3. And I want to do half. So let's just say I want to pick 200 for theta, 200 degrees for theta. Half of that would be 100. So I'm going to end up in quadrant number 2. And tangent in quad 2 is going to be negative. So I'm going to pick negative. Okay. 1 minus cosine is going to be cosine of theta. So here's theta, negative 2 over 5. Okay, that's what happens when I minus. Then I'm going to divide. I'm just going to make this radical a lot larger. There you go. 1 plus, and the cosine of theta again, so that's going to be a negative 2 over 5. So a negative and a negative will make it a positive. Okay, so negative is still in the front. I'm going to change it into 5 over 5. 5 over 5 plus 2 over 5, and divided by, I'm just going to write this division this way. So divided by, change this 1 into a 5 over 5, subtract 2 over 5. Okay. From here, bring down that minus sign in the front. 5 plus 2 is 7 over 5, divided by 5 minus 2 is 3 over 5. Subtract. Okay. So I'm going to multiply by its reciprocal, which I need to move up. So 7 over 5 times 5 over 3. The 5's are going to cancel. So my answer is going to be 7 over 3 into the radical. You need to rationalize this. So multiply this by 3 and by 3. So right now you have a negative. 7 times 3 is 21. All over 3 times 3 is 9. Well, square root 21, not much we can do. So I'm just going to write square root 21. But square root of 9 is 3. So that is my final answer for tangent of half. Okay. And again, if I'm really, if I speak too quick for you to write, please just stop ask your substitute teacher to stop if this is a sub day. If this is just on a regular video notes day, then just pause it. Okay, pause it and then write. Okay, so here is where I'm going to flip over. Hopefully you guys are okay with that. Example 4. Is this our last example? Yes, it is. Okay, example 4. Establish the identity. There's only one example for this there's only one problem for this last example. So we're going to work this out. All right, so cosecant of double angle equals 1/2 secant of theta times cosecant of theta. So what we want to do is, anytime you're asked to prove an identity, always pick the half angle or the double angle. It's easier to go half and double to a single than the other way around. Okay, so I'm going to pick the left side, cosecant of double angle. I don't know what cosecant of double is. I've never seen that before. So this is, we're proving right now, or we're trying to write a proof to come up with a new identity for cosecant, because we do have an identity for sine. So that's what I'm going to use. 1 over sine of double angle. Okay. So we have an identity for sine, double angle, and identity, or 3 identities for cosine. But we don't have any for tangent, or cosecant, or secant, or cotangent. But that doesn't mean we can't write it ourselves. Okay, so step 3. 1 over sine of double angle is 2 times sine of theta times cosine of theta. Okay, then from here, step 4, this is 2 times sine of theta times cosine of theta. So technically, I can separate them. So 2 times 1 over 2 times 1 over sine of theta times 1 over cosine of theta. Okay, so when you are multiplying, all you have to do is multiply across. Okay, so on the denominator, you're still going to be the same. So the next one is 1/2. There's not much I can do about 1/2. So guys, you can't really take the reciprocal of 1/2 and call it 2 and say that's the same. That's not the same. 1/2 is not the same as 2. But 1 over sine, I can take 1 over sine is equivalent to cosecant, right? Of theta. 1 over cosine is equivalent to secant of theta. And these two, even though I'm writing out of order, but they're exactly the same thing because multiplication is commutative. And this is the end of my day. I'm going to do a happy dance. Okay. Should I give you another toddler joke to end the show? Okay, here we go. Why does no one talk to circles? So how come no one talk to circles? Because there's no point. Ha ha ha. Get it? Circles. There's no point. It just goes in circles. Anyway, that is the end of my day. I'll see you guys next time.